So in this lesson, we're going to look at radians. We'll talk about what that is in a second here. And actually, I'm going to start out by showing you this GIF animation here. So there's a radius, and then it's going to swing around. So the red thing is the radius, that's R. And then they're going to move this radius to the outside and wrap it on the circle like that. So 1 radian is the length of 1 radius on the outside of the circle. There's 2 radians, 3 radians, and then halfway around the circle is called pi radians. That's 3.14 approximately radians. So then all the way around the circle would be 2 pi radians. And so what we're going to do is we're going to look at how to convert from degrees to radians. Here the animation goes again. We'll move on here in just a second. If you want to watch it one more time, here it is. So there's the radius. They're going to wrap that around. So 1 radian, 1.0 radians, is that red line right there, or that red curve. Okay. So we'll talk about what a radian is, how to convert, and then that'll kind of be it. And then the next unit, we'll talk about radians on the unit circle itself. All right. So what is a radian? Well, a radian is an arc length that can also act as an angle measure. So a lot of times as you get further along in math, you don't say 90 degrees, you say that in radians instead. So a couple of these we already know just based on the animation that we looked at, but we'll do a little bit more. So let's start with 180. That was the first one they kind of showed us. This was pi radians, and 360 was 2 pi radians. That was just from that animation. If you don't get that, watch the first minute of the video here. 0 degrees is 0 radians, so those radians and degrees are the same there. So how would we figure out something like 45 and 30 degrees? How many radians would that be? Well, 45 looks like it's maybe around 1 radian, but let's figure it out exactly. So one that I didn't ask you to do is 90, but 90 is going to be half of 180. And so that's going to be 1/2 pi radians, because 180 is pi, half of pi is 1/2 pi. So we usually write this as pi over 2. So for 45, that is half of 90, and half of a half is a fourth. And so this is going to be pi over 4. And we're going to spend more time in the next video talking about all of the values on the unit circle, but we're not going to get into that today. But I would actually strongly encourage you to try that. If you pause the video, try it, and then tomorrow, or in the next video when you watch that, make sure that you check and see how you did. But otherwise, you can wait till the next video. Okay. Another way to think about this is that 45 is 1/4 of 180. So 45 times 4 would be 180. So if we use that logic, 30 is 1/6 of 180. So this would be pi over 6. And if you're not sure how to get that, you could do 30 divided by 180 and convert that. That would be 3 out of 18, which is 1/6. So all of these radians are really using ratio and proportion to kind of find. It's almost like, if you're wanting to double a cookie recipe, you would, double everything. If you want to take half the cookie recipe, you take half of everything. And that's kind of what's happening is pi is like, the normal, and then all of these values around the unit circle are going to be a fraction of that 180. So in general, to convert from radians to degrees and vice versa, there's a few different formulas, but I'm just going to show you one thing that will always work, okay? So we're going to set up a ratio. It's going to be degrees over radians is going to be equal to degrees over radians. And obviously that, I'm not saying anything super complicated here, but we know a couple values on this, And we'll just start with the one that's probably the easiest. We know that 180 degrees is the same as pi, so we're going to set up that ratio. And then all you have to do is know one of these two things. So this is going to be your converting formula, essentially. Just use the 180 in pi, and then whatever you know on the other side of the fraction, fill that in, and you'll just be missing one thing. So we'll cross multiply, and actually we'll do a few examples here and show you what I mean. So we're going to convert these angles to radians. I'm going to do 180 over pi, and if you did pi over 180, that's fine. You just have to make sure that you flip the other fraction as well. So since we have degrees on top, we're going to do degrees on top of the other fraction, so 120, and then I'll just put x. Okay, I'm going to cross multiply. I get 120 pi equals 180x. And I'm going to divide by 180. And then we just reduce that fraction. And so 120 over 180 would be 12 eighteenths. So 12 pi over 18. And both 12 and 18 are divisible by 3. Actually, they're divisible by 6. So this would be 2 pi over 3. And there you have it. That's all you have to do. So you set up a ratio, you cross multiply, and then you reduce the fraction. There are ways to reduce fractions on calculators. If you need help with that, I would encourage you to either Google it or ask your teacher. Okay, let's do a couple more. If you want to pause it and try these two on your own and then unpause it and see how you did, that'd be awesome. But I'll run through 36 right now. So 180 over x equals 180 over pi. I messed that up. Equals 36 over x. And so this thing's never going to change, that 180 over pi. That's always going to be there. Then on the other side of the fraction, you're just going to fill in what you know. Okay, cross multiply, we get 180x equals 36 pi. Divide by 180. And we get x equals 36 pi over 180. Now, I know they're both divisible by 6, probably more than that, but let's just do 6. 36 divided by 6 is 6. 180 divided by 6 would be 30. So then these are both divisible by 2. That'd be 3 pi over 15. Both of those are divisible by 3, so it would be pi over 5. All right, so basically this is a lesson in cross multiplying and reducing fractions. All right, and then 270 is going to be 180 over x equals 270. God darn it, I did it again, didn't I? Struggling. 180 over pi equals 270 over x. Cross multiply, we get 180x equals 270 pi. Divide by 180. And we get x equals 270 pi over 180. We can divide by 10, so we get 27 pi over 18. Both of those are divisible by 9, so this would be 3 pi over 2. All right, so hopefully that makes sense. It's very repetitious. As long as you know how to cross multiply and reduce fractions, you're good to go. Okay, we're going to do the other way now and see how this goes. So same setup. We're going to do 180 over pi equals x. We're trying to figure out the degrees over pi over 12. Okay, cross multiply, we get pi x equals 180 pi divided by 12. And then I'm going to divide by pi on both sides. And that's going to cancel out that pi. So we're just left with x equals 180 divided by 12. Let's see. I think they're both divisible by 12, but I don't know 180 divided by 12 off the top of my head, so let's divide them by 6, because I know 18 is divisible by 6. So this would be 30 over 2, which is 15. All right, so pi over 12 is the same as 15 degrees. All right, let's try 5 pi over 6. Same setup, 180 over pi, I almost did it again, equals x over 5 pi over 6. Cross multiply, we get 180 times 5 pi over 6 equals x times pi. Now we would do 180 times 5, which is, let me type that in my calculator, 900 equals x times pi. We can divide by pi to cancel out the pi's, and we get 900 over 6 equals x. 900 divided by 6, I think is, yeah, it's 150, so x would be 150. All I did was I just did that in my calculator. If it ended up being if we got a decimal, that would be fine as well. Okay, last one, 9 pi over 5. So 180 over pi equals x over 9 pi over 5. Cross multiply, we get pi x equals 180 times 9 pi over 5. So I'm going to do 180 times 9, which is 1620. Woo. Divide by pi to cancel out the pi's. And we get x equals 1620 over 5. Obviously, it's divisible by 5 because it ends in a 0. So I'm going to divide that by 5, and I get 324. All right, so that's it. If you watched one of these problems, you probably got the hang of it. But hopefully a little bit of repetition helped. So that's going to be the main focus of today, is converting from degrees to radians, radians to degrees.